This is Chapter 16 of Learning Web Design, which describes commonly used techniques for laying out pages with CSS. Some design problems are so common that we arrive at a standard set of solutions for them. We call these standard solutions design patterns, a term that originated in architecture and was later adopted in software engineering. The general idea is that by agreeing to refer to each problem and its solutions in a standardized way, designers are better able to communicate with each other, to learn from each other's successes as well as their mistakes. While the author never mentions it, the design pattern idea underlies most of the discussion of the advanced topics in the book. A problem is presented, and then one or more solutions are given, each with its noted pros and cons. In what follows, we'll use the language of design patterns, describing a series of common design problems and their solutions. Page layout is probably the most fundamental problem in web design. In the earliest days of the web, commercial browser makers competed to come up with HTML tags that emulated the layout features of word processors. Within a few short years, the HTML-only approach met a dead end, with the inherent conflict between information design and visual design proving to be too much to overcome with HTML alone. The solution was CSS, which looked for inspiration from the print design industry, adopting much of the same terminology and even the measures in use by commercial printers and graphic artists. While this approach certainly was a big improvement, with reusable style sheets, advanced typography, and pixel-perfect control over the layout of the page, there was an inherent problem that became apparent even then. The web is not a print medium. In print, the designer controls, or at least knows, pretty much everything about the medium, down to the size of the page and even the texture of the paper. On the web, there are no such guarantees, with page dimensions, fonts, bandwidth, and a host of other factors beyond the web designer's control. So, the web page layout problem is this: how do we design pages to work well without knowing much, if anything, in advance about page and content dimensions? As we learned in chapters 14 and 15, CSS's box models and normal flow rules place heavy emphasis on element width. Thus, it's no surprise that the solutions to the layout problem also come down to how one defines the width of the page and its contents. The first solution, called fixed layout, uses pixel measurements to recreate as closely as possible the level of control expected in print design. Fluid layouts, by contrast, make all widths variable as a percentage of the available space. The page and its contents appear to stretch and shrink with the dimensions of the browser window. Elastic layouts base all dimensions on the text size, an approach that can work pretty well on text-heavy sites where readability is the primary concern. In fixed layouts, the width of every element is specified in pixels, making dimensions remain exactly the same regardless of device width. Fixed provides the graphic designer precise control over every aspect of the visual design. Designers will often produce a reference mock-up that looks exactly like the intended page design, including the final graphics, fonts, etc. The web developer will then carve up the mock-up to design the HTML and CSS to match. This is much like how printers have worked with graphic designers for hundreds of years. To an old-school graphic designer, any other approach is likely to feel alien, unprofessional. There are at least three basic problems with fixed layout, all having to do with variable device widths. On small screens, users are forced to scroll horizontally as well as vertically because the page is wider than the device. Two-dimensional scrolling is a known usability problem for all but the most skilled users. On large screens, there is the issue of what to do with the extra space. Usually it appears as large margins, which can easily become wider than the actual page content. The second problem is that there is no guarantee that the user won't substitute their own fonts, at their preferred sizes, only to have the text not fit in the allowed boxes. This leads to the final problem. This inflexible approach does not allow the user much freedom without potentially breaking the design. So, to sum up the fixed layouts approach, it's great for working with print mockups, but potentially painful in practice on the web, especially on small screens. Here's the CNN website at full width on a 24-inch monitor. The page has a fixed width of 980 pixels, leaving sizable margins at either side of the page. Together, the margins cover more area than the content. Text zooming does not play nicely with fixed layouts either. On the top is the CNN masthead at normal text size. On the bottom is the same masthead with text enlarged for users with poor eyesight. Words are cut off, both horizontally and vertically, because overflow would otherwise break the design. All white space is lost as well. While fixed layout is now out of vogue, many of the concepts that grew out of it are still in common use. Perhaps the most influential is the use of a grid to normalize element widths. Such a grid slices the page into columns and gutters. The left and right edges of each element are aligned to the columns. In many respects, this is just like the tables used in old school websites, just with CSS instead of the table markup. Here on the American Institute of Architects website, we see the 960GS framework used to slice the page into a grid with 12 columns. Each element spans some number of columns, sparing the page designer the chore of defining the pixel widths manually. Instead, they can simply use a CSS class to indicate how many columns to span. This approach makes the conversion from Photoshop mockup to web about as painless as possible. Fluid width layouts solve many of the problems of fixed width layouts. Instead of using pixels, they specify everything using percentages, so that element widths scale with screen width. Fluid widths avoid fixed layouts' wide margins on large monitors. However, like the fixed layout, there is still the potential for line length problems, only the problem is less about having not enough room to fit the text than about having too much horizontal space, causing very long line text lengths that significantly affect readability of the text. On smaller screens, fluid widths adjust nicely. However, there are limits to how well fluid widths can work on multi-column designs. You can only narrow a column of text so much before it becomes unreadable. This is sort of the opposite of the long line length problem. What happens when the line length is shorter than a word? Finally, some designers find fluid layouts challenging because they cannot handle the added math needed to work with the percentages. To determine the width of an element in pixels requires the designer to multiply the percentage by the container width, which itself may be expressed as a percentage of its container, and so forth. The W3C website uses a 3-column fluid design that works pretty well at most screen widths. For the smallest screens, where the columns would be too narrow for the content, they switch to a 1-column format. These days, almost every new website is designed and built on top of a framework that handles the most complex technical problems, so the designer can concentrate on the user's needs instead of code. Virtually every one of these frameworks incorporates a fluid version of the sort of grid used in the 960GS framework. One of the more popular frameworks is Bootstrap from Twitter. It's designed with a mobile-first progressive enhancement approach in mind. One particularly useful feature is that its grid can adapt to allow more columns on larger screens. On a cell phone, everything is laid out in one column, but on a small tablet the designer can add a second column, and then add a third column on larger screens. These kinds of layout changes occur at preset breakpoint widths, which can be controlled by the designer. Besides providing a fluid grid, it also gives elements like buttons, form fields, etc. that can be made to work with fluid widths. It's even possible to show or hide elements depending on the device width. Newsweek's website was rebuilt in late 2013 using Bootstrap. Some things to note are the use of a breakpoint to add a second column on larger tablets and desktops, and the use of responsive images to scale to fill the available space. Even the font size in the titles varies, with smaller text on phones and larger text on tablets and desktops. Finally, note that the menu items on the top menu of the page change to accommodate the screen width. Elastic layouts are more of a theoretical idea than a practical alternative for most websites. They scale everything to match the base text size, measured in M widths. The advantage is that there are no line length problems like those with fixed or fluid designs. This makes elastic design a reasonable choice for text-only websites. However, it also comes with some disadvantages, including many of the same ones as fixed layouts have on mobile devices. Many sites mix and match fixed, fluid, and elastic measurements as needed to suit the situation. For example, many otherwise fluid websites use M heights for content in order to keep larger text from overlapping with the lines above and below them. Another common case is a fluid website that accommodates banner ads or other fixed width content. In Chapter 15, we introduced the basics of multi-column layout using floated columns. By floating each column, we break normal flow by displaying blocks side by side, while simultaneously restoring normal flow within each column. In a traditional fixed multi-column layout, the entire page is contained in a wrapper that keeps the widths of the page constant. Any extra width within the browser window appears as margin outside the page wrapper. Inside the page wrapper, each column is floated left and given a predetermined width and horizontal margins. The widths of the columns and margins should exactly add up to the width of the wrapper. Here we see a 2-column layout with 20 pixel gutters. The second column, Extras, has 0 left margin so that the gutter stays at 20 pixels. The footer clears the float of the column above it so that it spans the width of the page. This is the same basic layout with fluid widths. As long as the column widths plus margin total 100%, there's no need for a page wrapper. Once again, the footer clears the float of the column above it. The same basic idea works for 3 or more columns. Just float each column to the left and add margins as needed for the gutters. Typically, the first column has left and right margin, while the others only have margin on the right side. While this basic approach works great in modern browsers, in the early days of CSS adoption, there were lots of quirks that caused layout to vary slightly from browser to browser. Over time, one basic technique, called the Holy Grail layout, finally provided a consistent experience in all the browsers at the time. However, it included lots of styling that targeted bugs in each browser, resulting in CSS code that would seem nonsensical today. One idea that some people experiment with from time to time is using absolute positioning for the columns. Rather than being a design pattern, this approach is more like an anti-pattern. What not to do. For instance, footers don't work because there is no way to know how long each column will be. A partial solution is to use static positioning for the longest column so the footer can come next in the normal flow. However, this requires knowing in advance which column is going to be the longest. If you guess wrong, then the column will overlap with the footer. There are some situations where we might want to display the columns in a different order than they appear in the HTML source. For example, to improve a site's ranking in Google searches, we might want to have the left sidebar appear after the main content in the HTML. The solution is to reorder the column display in CSS by applying negative and positive left margins to slide the columns to the left and right. This illustration from the book shows the technique. The links column appears after the main and news columns in the HTML. Having the content appear before navigation in the source file increases the odds of the search engine finding a match to a word or a phrase. The designer uses negative left margin to align the links column to the left side of the page. And then, to make room, the designer adds positive left margin to the main column that forces it to the right. The news column remains untouched, though it's pushed to the right by the main column until it's flush with the right edge of the page. One of the advantages of using floated columns is that the columns don't have to be the same length, allowing them to stretch vertically as needed to fit the content. However, this presents a problem if the columns are supposed to appear as if they have equal heights. This can happen, for example, if colored backgrounds are given to the columns, leaving white gaps at the bottoms of the shorter columns. The solution is to use a background image for a container element, or the whole page. It includes background decorations for each column. The header and footer then get their own backgrounds. Here we see a background image that's yellow with a textured edge on the left and green on the right. When the columns are layered on top, the background spans both columns for the full length of the longest column. The faux column technique was first devised when most websites use fixed layouts. To use it for fluid layouts, where the widths of the columns are not known in advance, we have to shift the background left or right to make the images align properly with a gutter between the columns. To be safe, use a really wide background image, just in case somebody has a really wide monitor. Here we see the fluid faux column technique in use. A really wide two-color image is positioned using percentage units so that its offset matches the width of the first column. The same technique works for 3 or more columns. For each additional column, add one more background image and then position using percentage offsets. We close this chapter by reiterating the advice to use a framework to simplify page layout. Why reinvent the wheel with each design project? The most successful frameworks grew out of the work of professional designers solving real problems for real clients. These frameworks have been road tested, debugged, and tweaked to do most of the really hard work of laying out pages for us. Unless you really have a hankering to innovate at a fundamental level, there is no need to do all of this work yourself. Instead, focus your attention where it belongs, on the website you're trying to build. There are 2 classes of CSS frameworks in popular use. CSS-only frameworks like 960GS, Skeleton, and Pure CSS are designed to be very lightweight, with tiny file sizes that don't add much to the page weight. The alternative is a framework that combines CSS with JavaScript to provide effects that can't be accomplished with CSS alone. Bootstrap, which we've already mentioned, is developing a very large following, especially for the mobile web crowd. Its main rival, Foundation, is likewise attracting a lot of attention and has a lot of the same features. Both frameworks are pretty heavyweight though. Foundation, for example, weighs in at over half a megabyte, which can take 8 to 10 seconds to download over a slow Wi-Fi network, and much longer than that over a cell network. Thank you for following along with Chapter 16 of Learning Web Design. See you later!